It's time for a practical end-to-end example, which I'm going to subtitle, How to Set Up Your House for Voice over IP. And I love doing these kind of nuggets, it's just so pure. It's so, like, let's just do something fun and cool. Now, keep in mind that everything that we do in here, I'm going to try and take almost every concept we've talked about in the series up till now and kind of blend it into one practical hands-on example. But number two, keep in mind that everything that we talk about in here, while I'm applying it to a house, can easily be applied to corporate America in just about any scenario. So here's what the scene looks like. I've got a Cisco UC520, which is a pretty nice router that's sitting right here, and you don't have to use this. You could use, like a Cisco 2621 XM, or even a Cisco. I mean, you could probably do this for under $100. If you shop right on eBay and buy the right kinds of devices, like a Cisco 2610 might be able to do this with some old voice modules. I mean, you can definitely piece this thing together. So I'm using the Cisco UC520. I've taken my home phone line and disconnected it and plugged it into the FXO port. Now that is a single analog connection out to the PSTN. And I've got a couple devices plugged into the FXS ports. Now these are our analog phones. I'm going to assign them extensions. And I'll say if I wanted to keep it simple, I could stop right there. And set up the dial plan, get the internal, external calling all working. We don't need this device down here. I just kind of added that to add in the voice over IP dial peers and, changing codecs over the WAN link and all those kind of things just to add them in. But again, if we're keeping it pure house, obviously not necessary. Now, how do I translate this practically into your home? Well, most homes, if you look at them, have a line coming in on the street, a box mounted on the side of the house, and that represents your phone line. What it is actually doing is feeding a loop inside of your house. It goes to every phone jack, whether it runs through the attic or baseboards or whatever, where you have your actual phone handsets attached. And that's why you can sit in one room and be talking on the phone and yell, hey, pick up the line, and somebody in the other room picks up the phone and you're both sitting there on the same phone call. It's because it's all actually riding on the same set of wires. You're just linking the handset to it. Now, here's what I would suggest, and this is when I first got into voice over IP. This is what I did just because it was fun. Is I initially took out. I know some of you are like, "Fun? What kind of sick person are you?" No, seriously, it really is once you start doing it. So back then it was a 2600 something, really low end router, which was high end back then, and I took the phone line from the box on the side of my house and I disconnected it and ran it straight to the router to where that went into the FXO port. So literally, think of the router as it's bridging in right here to the street. Now, I started this by then taking the loop that was coming out of there and bridging that, taking that and wiring it straight into the FXS port of my router, which was kind of cool because I could pick up and dial 9 for an outside line on any one of these phones and make an outside call. But in the end, I kind of sat down and I looked at it. I was like, well, I've replaced the box on the side of my house with, for that time, it was a pretty expensive router. And I was like, and what benefit did I give it? It was cool. That's about it. I can dial 9 for an outside line now instead of just dialing out. Isn't that neat? So what I started doing was, instead of using this big shared loop in my house, I started running individual lines from these phones into different FXS ports on my router, because at that point now they're different devices and I can assign them, this guy is extension 1101 like I have over here, or this guy's 1102, and now I can call between the rooms of my house. When a call comes in, I can say what phone actually rings for that incoming phone call. So I can start doing a little bit more. Now eventually, and this is where this series is going, eventually I got rid of the analog phones. And I replaced it to where this now connects directly to a switch, and this became a Call Manager Express router. To where now I have real IP phones, real power over Ethernet switch, and now eventually, and by the way, the FXO port went away and ended up being replaced by a SIP trunk, which we're going to talk about later. I think the first company I started this with was a company VOIP.ms. or Vonage. Maybe I did it straight to Vonage. I think there was somewhere in there was Vonage, and I had a little adapter going to an FXO port. And I was like, this is lame. And Vonage wanted something silly, like a couple $100 a month to have a straight SIP trunk, and I was like, forget that. So this company I went with simply because it was like no startup cost. You just pay like a penny a minute for any phone call you make, and I was like, well, that's easy. So that's the end of the road. Now that's where we're going. And think of this as like, okay, that was the practical example. That's the sneak peek as to where this series is going. Is we are converting our whole network to voice over IP, but for now this is where we begin, so let's get started. Now I absolutely love starting with a clean slate, so that's what I've done here is blown away the configuration. All I've done is applied a host name, UC520, for this router, and I've given an IP address for that quote-unquote WAN link over there to the other router, 10.1.1.1, which is great. Now, currently everything's down. There's no activity on the individual ports until I bring up the other router, so we'll get there. For now, let's just do the base configuration here. I'm going to go into global config mode, create a dial peer. We're going to say dial peer voice, and we'll do 1101. Again, the tag doesn't have to match the extension number, but often it does if you have single extensions like this, and this is going to be a POTS dial peer. I'm going to come in and say destination pattern 1101. Oh. Port, and let me just get us reoriented here. Do show voice port summary. And I've got FXS 000 and 001, just like I've labeled here on the diagram. So I'll type in port 000 for 101. Let's exit back out, hit the up arrow a couple times, and we'll do dial peer voice 1102, which is going to be the other guy down here, 1102, and then over here at the other office is going to be 2001. We'll get creative when we get there. Destination pattern 1102, port 1 or 0/0/1, which is going to be this next one. So just like that, we now should have local connectivity between these two. I'm going to do a show voice port summary, and literally I'm going to lift up. I don't even know where this cable goes. You can see, okay, I'm on this one because I just see it went off hook. So I'm going to dial 1101. Ring, we have ring, good. I'm going to lift up the other phone, which is now sitting here, and I'll turn on some debugs later on so we can actually see the dialing and do 1102. Yeah, that's what I'm talking about. Bring in phones. You know what? I'm such a fair weather technology guy, but here's what I mean. When I first got into voice over IP, I was actually thrown into it. I got my CCIE in routing and switching for Cisco, and then got thrown into voice just because they're like, nobody else wants to do it. Jeremy, you get to do it, and I hated it. And the mantra I took when they're like, so do you like voice over IP? I'm like, no, and I would always follow it up and say, it's not fun just making phones ring. And it's funny because as I fast forward through the years of my life, and really once I got and understood voice over IP in all its glory, the reason I found later on, hindsight, the reason I didn't like it is I just didn't get it. I didn't really care about it. It didn't interest me. But once I really got it, I'm like, this is freaking awesome. And so I know some of you are like, he just likes hearing phones ring. And yeah, I kind of do now. It's kind of fun. So we've got local connectivity between these two. Now let's go beyond. I'm going to go to the FXO port right here. And where's my pen? Here we go. I'm going to get this guy configured with some dial peers so that it's able to make outbound calls first, and then we'll worry about the incoming calls. So if I'm going down my list here, I've got the FXS dial peers, which are created and ready to go. Now FXO. Now as I do this, just from some of the previous nuggets where we've talked about the wildcards and what you can do with the dial peers, you know that we can create a really easy dial peer that says to reach the PSTN, dial 9, if you will, for an outside line, and then T, which is unlimited digits. Well, the problem with that is the router will sit there for that interdigit timeout, which is 10 seconds on some iOS versions, 15 seconds on others, before it's going to forward the call. So that's not a good strategy to create a dialing plan using the T, except in the cases of international. So what I'm going to do is create a dialing plan for the North American numbering scheme. Now here in Arizona, we do 10-digit dialing. So that means we have an area code. So for example, I'll give you 480 is one of the area codes here in Arizona. Then we have a prefix, and then 4 digits after that, the suffix. So I'll just put 480-555-1111. Or I have 602 is another area code. Now we can dial any of these without needing a preceding 1, which indicates long distance here in North America. So 602, we have 623. I mean, we have a number of quote-unquote local area codes that we can do, but everything is a 10-digit number. You know, we dial using 10-digit schemes. Now, other areas have 7-digit dialing, to where, you know, it's a smaller area, so they don't have multiple local area codes, so they just dial 7 digits. The concepts are the same in how you want to apply this. It's just how many digits you want to send along. So the first thing I'm going to do is I'm going to create on here one dial pair for 10-digit dialing, one dial pair for 11-digit dialing, one dial pair for, and by the way, this is considered long distance, one dial pair for international dialing, and then I'll add in one more for emergency calling, which we don't want to forget about that. So I'm going to go on to the router, and let's exit back out here. And I'm going to type in dial pair. And let's just start with, you know, I've got a couple of them, 1101 and 1102 right now. So we'll do dial pair voice, and I'll just start, you know, this is where it can get a little random. Maybe I'll say 10 will be my first dial pair, POTS, because I'm going out an FXO connection. Destination pattern, well, before I even get there, let's do a description. This is really handy to put these under here. And I put my descriptions in all capital letters so it stands out to me when I do a show run, just a habit I have. So we'll do description. This will be 10-digit local dialing. And then we'll do destination pattern, 9 for an outside line, and then 10-digit local dialing. Now one of the things I want to make sure of is that this does not get confused with long distance. Matter of fact, you know what? I'm going without a net here. Let me back out and let me do long distance first. I'm going to do dial pair voice 11 POTS. We'll do description, long distance dialing, destination pattern, and I'll do 9 for an outside line. So when somebody picks up 9, I get that outside line, and then 1 as the second digit. Because, you know, our long distance, so that would be any other area code in the United States. Might be like 1, let's do 520, you know, 111, 111, whatever. Again, 10 digits after that. So I'm going to have 1 being the initial, and then I will put ... That'll be the area code, ... prefix, ... suffix. So there's my 10 digits following the 1. And I'm going to forward that out port. Let's do port 0/1/0. That's my FXS port. Now, it's one character beyond this, or one step beyond this. I've got the 4-digit commands. By default, you might remember this, but by default, POTS dial pairs, any POTS dial pair will automatically strip explicitly defined digits. So if I leave it as it stands right now, it's going to strip off the 9 and the 1 because they're explicitly defined. Now, only POTS dial pairs do that. Voice over IP and all the other dial pairs don't do that. Cisco did that as a convenience to you because a lot of times you do want to strip off, for instance, a 9 from that because you don't want to send that to the PSTN. But instead, what I want to do is I want to overrule. I'm going to say, well, I need the 1 to be on the PSTN, so I'm going to use the forward -digits command, and it says, okay, what number of right justify, that's the key, the right justified dialed digits. Now I've done it. Right justified dialed digits do you want to forward? So when you're thinking about this, think of, okay, counting from the right, how many digits do I want to send? Now, let me give you this environment versus a real environment. In a real environment, we would definitely say 11, because that would say I want to forward everything up to the 1. The 1 is included. That's the 11th digit from the right. And I want to strip the 9. But let me describe my environment a little bit. My environment is a little wacky because I told you I set up my house long ago for voice over IP. So this is actually coming in from a voice over IP carrier right here. And I actually have my own phone system So I'm actually building a phone system behind my own phone system inside of the house, and I'm feeding. This is actually an adapter known as an ATA adapter. That is, it's taking my voice over IP connection, which is coming in right here, and converting it to an analog FXO port, or I guess you could say FXS on the way out, which matches to the FXO port on this side. So this is where it gets a little wacky. Is in my environment, this phone system we're building right now is going through my phone system, which goes to the phone carrier. Did you follow that? So my phone system requires a 9 for an outside line. So the difference is going to be in this environment, we'll call it bizarro land, phone system to phone system, I'm going to keep the 9 on there because otherwise the call will not go out to the other side. So I'm actually going to say 4 digits 12, or I could add on there 4 digits all. Either one of those will work just fine to forward all the digits that were going to be dialed. So that's my long distance. Let me back out and now go into here. Oh, let me just go to dial peer voice 10. Let me do a show dial peer voice summary. I'm going to give you that view because we've got 10, which is currently down. It's not working because we don't have a destination pattern or a port number. There's our long distance one. It's currently up. It looks like it's good. So long distance was working. Now what I'm going to do, and this is why I wanted to do the long distance first, is say dial peer 10 is going to be, I already put the description. I'll put, will be the destination pattern 9 and then anything but 1 dot dot oop dot 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 dot. Now wait a sec. Hang on. Did I do that right? No. That's 1 digit too long. So what I'm saying here is this first digit, and you got to make sure those dots are right. That will cause pulling your hair out troubleshooting. This first digit can be anything but 1, and then it will be 1, 2, 3, 4, 5, 6, 7, 8, 9 dots after that, right? Because we're talking about 10-digit dialing right now. So I'm going to go back there because I think I added a different one. So we've got 9. Then the first digit, again, this represents 1 digit, will be anything but 1 dot dot. That's 2, 3, 4, 5, 6, 7, 8, 9. That's better. That looks much better there on the destination pattern. And that does replace the one that I typed in. It's not adding destination patterns or anything funky like that. Now, why? Why, Jeremy, did you make this anything but 1? How come you didn't just go simple and go like, something like that? Right? How come we didn't do that? The reason why is because the router always uses immediate matching, meaning it's going to look at the dial peers, and now I've got 10 and 11, and I've got 10 being 9. Let's imagine I didn't use the anything but 1. So if I said 9 dot 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 dot, right? There's our 10 digits. And then the other one I said 9 9 1 dot 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 dot, right? Same kind of thing. So this is our 11 digit, this is our 10 digit. Well, do you see what could potentially happen here? If I dial 9 and then dial 1 to start making this long distance call, 9 1, now it's matching this and this, and I dial 520 111 111, done. I lose the last digit. Here's where the last digit would go. The reason why is it matches this because this matches, the 1 right here, and so does this. But this one reaches the end, and as soon, and this is the rule of routing, as soon as it gets an immediate match or a specific match, it's done. It's not going to wait for you to dial that extra digit over there. Now, if you have some experience with Call Manager or CUCM, this is a different behavior than what it is on the Call Manager. Call Manager, if it has an overlap like this, will sit there and wait. It's going to be like, okay, you going to dial that extra digit? Because if you do, it matches this one. But if you don't, then it's going to match this one. Not so on the router. The router's like, immediate match, you're done. It's forwarded on. So that's why we have to exclude 1 from this one. So as soon as I dial a 1, it's like, you are excluded for matching that. You are now matching dial peer number 11. Does that make sense? So we have to associate this with port 0/1/0. So now, hit the up arrow a couple times. Now I've got 2 alive dial peers. We've got 10-digit dialing. We've got 11-digit dialing. That's our long distance that's working in there. And by the way, just to give you a little flexibility, I could have, instead of saying anything but 1, I could have done it like this. I could have said 9, 2 through 9, bracket like that, and that would have worked as well because 0 is also excluded from normal digit dialing in in North America. So that would have worked as well, but I went the other way. So now we need international. Now in North America, to reach an international number, I call internationally so rarely, I actually had to look it up. I'm like, oh yeah, that's how I do it. You pick up the phone and you dial 011 and then whatever the funky international number is. So this is our I'm dialing international code, and then we put in the international numbers, because outside of the United States, numbers look weird. Different countries use different schemes, things that we're not used to, or I should say, because I know I'm talking to a lot of international people. You're weird. I shouldn't say that. Your country is very different in the numbering scheme, so we have to use different dialing to do that. Now, here's the big problem. When we're dialing international, there's all kinds of different schemes. And the same thing, if you're international and you're dialing North America, I mean, there's all kinds of different schemes worldwide that are being used. So do we create a numbering plan for every single country? I mean, hundreds of different numbering plans? Well, you could, but I would say most people do this. They're going to go in, exit out. Let's do dial peer voice 12 pots. Description. International. Destination pattern 9011T. Very commonly done that way. Now, I know what you're thinking. You're like, okay, whoa, wait a sec. You just spent some time saying T is going to add an extra delay because the router is waiting to see if there's more data. Will that add a delay here? Yes, it will. Is that bad? It could be, but let me just say this. There is a persona, and we probably all have it. It's like when you pick up and dial international, there's something in your mind that's like, okay, I'm not hearing anything, but that's probably because this call is flying around the world and the satellites and somewhere in the middle of being amazed at the fact that we can pick up a phone and dial somebody around the world, all of a sudden we go, oh, there it is. The call's connected and it's actually going through. Most people will use the T. Now, could you build international dial plans that match, very, very similar to what we have here for North America? Yes, you could. You could very easily. But it's just there's a lot of them out there, and most people are very content to do 9011T. Okay, so we're going to send that out the same port 0/1/0. Ooh, did I forget this? I think I forgot that on the other one. Dial peer voice 10. Make sure I got that in there. I can't remember if I put that there or not. So 4 digits all. Actually, I'm looking above, and I did not. So it's good that I put it in there. So now we've got international, and then finally, we do emergency calling. I'm going to say dial peer voice. Let's just call it 911 pots. And I'm going to say destination pattern. If somebody dials 911 in the United States, I'm immediately going to send that out port 0/1/0. And definitely don't forget the 4 digits all on this one. Because that, if it will strip everything. It's an explicit match, and it will send 0 digits out to the PSTN because they're all explicitly defined. So you have to have that 4 digits on there. Now that's people a lot of times when they call 911 are in a panic. They pick up the phone and they dial 911. They don't remember that they have to dial 9 for an outside line. So you'll see it all the time where people will create 2 dial peers like this. They'll have 911 and they'll also do 9911. In case somebody does have the right state of mind, they're like, okay, I need to dial, somebody's bleeding. I need to, dial 9 first for an outside line, then dial 911. So we can send out this port. And again, if we're doing this in the real world, I would say 4 digits 3 to only send these 3 rightmost digits and strip off that preceding 9 that's on there. Not too bad, isn't it? I mean, if you look at it, in 4 dial peers, we've created the entire dial plan for the North American PSTN. Now, you can go further. You can say, oh, well, what about like 411 for information? I mean, we have all kinds of service numbers, and it's easy. I mean, you could go in and you could go dial peer voice. Let's just do 13 pots. And I could say destination pattern. I mean, once you got the wildcards, you see how these wildcards are so handy? You could say, 1 through, bracket 1 through 8, dot will be our service numbers. Actually, we need a preceding 9 for an outside line there. 9, 1 through 8, why am I putting X's? Dot dot would be our service numbers, or you could even get creative. You could say, well, I only want to allow information. I think 611, if I'm wrong, not correct, is like local police department. I don't know what the other one. Let's say I just want to allow those three. Remember that? And I know when we were doing the wildcards, you're like, oh, okay, come on, why would I use that? Totally, you can use that to where you can say 9, 4, 6, or 7, and then dot dot, any 2 digits. Or we could even get more specific, 1, 1, 1, just like that, because that should be the only numbers that they're actually calling. This is pretty cool. Yes? So that's creating those service numbers, and then I can do port 0/1/0. Okay, good. Now, it's time to test it. I'm actually going to grab my cell phone and place an outbound call on my FXS port. Actually, I just changed my mind because I wanted to, sure, I'll call my cell phone, but I want to actually call something where I don't expose my own personal phone number to the world. So I'm going to do a debug dial. Let's see. Why? So they changed it. It used to be debug dial pure voice, but now they say debug is debug VoIP dial pure. Okay, so I can actually see that we've got dial pure debugging on. I'm gonna lift up my. Let's do my speakerphone here. You hear that? Yeah, that's good. All right, and I'm actually gonna go to the CBT Nuggets website right here. Look, I just created Amazon Web Services. So I'm gonna call their number. I'll do 9. For an outside line, 1 5 4 1 2 8 4 5 5 2 2. And I'm hearing beeping, which is I'm really curious why that's. I'm getting. That is interesting. I just had to pause the recording and look down, and I go, oh, I haven't plugged in the FXO port yet. So that's why it wouldn't be making that beeping noise saying there is no FXO line. So I've now connected that. I've plugged the FXO port in and disconnected my home phone line. But before I even bring it up again, you can see that during this debug, it's saying, okay, there's the called number. I've got this number that I've dialed 91541 the CBT Nuggets number. Calling number, that's the caller ID, that is blank. Because when it comes to FXO ports, you can't set the caller ID. That's set for you by the phone company. It doesn't. There's not enough bandwidth, if you will, in a little FXO port in an analog line to carry the caller ID information that I want to send, and it's not programmable. I mean, think about it. If the phone company even allowed this, people everywhere around the world could set whatever they want their caller ID to be when they're calling from their home phone, and you can imagine everybody's gonna be like, well, I don't want people to see it's me. I want to come from this person, and all kinds of craziness could occur. So caller ID is blank, call number is there. Now my phone system actually supports 10 and 11 digit dialing, and if I dial a long distance number if I dial a long distance number without the 1, it actually converts it and puts a 1 on there. That's just how I've set up my house. So all my dialing in my house is 10 digits. But I do want you to see it says outgoing dial pure tag number 11, which we know when we did that show dial pure voice summary. That's the long distance one. It matched that one. So let's just do it again. But this time I'm going to dial it with just 10 digits. I'm going to dial 9, and we'll actually watch it as it dials 5 4 1. A little delay on it coming up. 2 8 4 5 5 2 2. Waiting. My breath is held.
Thank you for calling CBT Nuggets, provider of information technology training solutions.
Fantastic. So we are now connected to the auto attendant at CBT Nuggets. You notice that I'm gonna hang that up because I can't think with her talking. So right there, I've got the called number. It's now a 10-digit number. My home network supports doing long distance as 10 digits, and you can see it matched the other outgoing dial pure tag number 10. So it's able to process that. It's able to handle that and send that to the place that it should go. So we now have outbound dialing configured on our system. So we've got FXO dial pure. As a matter of fact, let me just clean this off so we can just get a clean slate. There we go. And add on. We've got FXO, FXS, FXO. We did the 4 digits. Now let's talk about what happens if I place a call on the incoming. How does it handle that? Well, and I'm really trying to think how can I demonstrate that without showing the world what my home phone number is. Matter of fact, maybe I'm going to try calling it from my cell phone. Turn on a debug, and we'll listen. I won't tell you the number that I dialed, but we'll be able to see on the debug. We'll be able to listen to what happens on the cell phone, and then figure out what to do with it from there. All right, so I've got my cell phone ready. I'm going to pick it up and dial my home phone. Good. Okay, so I'm dialing it now. I'm going to put it on speakerphone. Listen. Hear that? So did you hear it? It went through two distinct phases there. The incoming call actually came in from the PSTN to the UC520. You saw the debug light up, and I know your eyes, if you're like me, are scanning that debug right now, going, what's going on? Okay, it rang, and then immediate busy signal. What's happening is it's saying, wait a sec, I just received a call where there is no. Well, I don't have caller ID set up here, but there is no calling number and there is no called number. So I just received a call on my FXO port, and there's nothing there, no match. That's where you get the busy signal. Now, I will tell you, this depending on your iOS version and the device that you're using, sometimes some routers will actually, you'll hear it go ring, just like it did, and then it'll go like you'll actually hear a second dial tone when the call comes in. What happens is the FXO port again gets shocked from the phone company. It goes, oh, I need to answer. It lifts up, but realizes it doesn't know what to do because it hasn't received any direction from the PSTN. All it knows is it got shocked and it picked up the phone. And so what does an FXO port do? It plays dial tone. It generates dial tone, and so what the caller hears is they dialed in your number, and all of a sudden they've got a second dial tone. Now, if they know what they're doing, if they expect it, they can actually dial an extension. They could dial 1101, and the FXO port will go, oh, okay, let me ring him or ring him. They can actually start making phone calls from your FXO port if they know what they're doing. But good grief, who on earth would know what to do when a second dial tone came in? So what we need to do is this thing called PLAR. So PLAR has a lot of cool purposes. It stands for Private Line Automatic Ring Down. What it's typically used for is for making emergency phones. Like, let's say I want to make 1101. Let me just see what's plugged in where. Yeah, I want to make 1101 dial 1102 as soon as I lift the handset. Some of you are thinking back to Batman with the red phone to Commissioner Gordon, right? Same kind of thing, or emergency phone in a parking garage or something. Here's all you have to do to create that. I go into my UC520. I'm going to go into Global Config, Voice port 000, and do a connection PLAR. And we'll say I want to do a connection PLAR to 1102. Enter. Now, as soon as I lift the handset, here I go. Lift the handset. Ring. Immediate dial. Hang up the handset. Right? It immediately dials 1102. I'm going to lift it again. Ring. It's kind of fun. Okay? Don't move. Don't breathe. Ring. So you literally can lift that handset and it reacts. It makes the emergency call, and we fill the screen with debugs because it's processing what outgoing dial peer is making that call. So how does this apply? Do you see where I'm going with this? On FXO ports, what we can do is we can configure this for connection PLAR so that when an incoming call comes in, it gets shocked, it answers the call, but then immediately knows what to do with it, right? So what I'm going to do is I'm going to go into global config mode. Let's go into voice dash port. The dashes are so inconsistent with that command. 0/1/0. Consistently inconsistent. And I'm going to type in connection. Matter of fact, I'll show you right here. We've got a tie line, a trunk. This is actually used when you are bringing up connections to PBX systems. But we're going to do PLAR. I'm going to say connection PLAR. Question mark, it says enter your string of digits. So I'm going to say, again, 1102. That's got a nice loud ring that we can all hear. Connection PLAR 1102. That is going to ring that phone. Now, you notice we also have this off-premise extension PLAR. That's a good one to use. What this does, if I just type in connection PLAR, is when the call comes in, it immediately connects it. Like ring, you are now bridged directly through to that phone, and it's ringing. If I do PLAR OPX, off-premise extension, what it does is it says, okay, I'm receiving it, I'm going to ring that phone, but I'm actually going to maintain control of that call. So if that phone maybe doesn't answer, I can send it to voicemail. Or if that phone, I can do something else with it. I can define a different direction for that call to go. If you just use connection PLAR, it just sends it its way and it's done with it. It says, I'm not going to get that back, I've sent it. So you get the idea. That would be very handy if I sent it down here to that's where the name comes from, off-premise extension, something not on-premise. So I don't just wing it down here to this guy and he now takes responsibility for it. I'm actually going to ring the phone, but I'm going to be listening for the connect. If it doesn't connect, then I can pull it back and maybe send it to voicemail. So that's the difference between the two. Let's test it. So I've got the FXO port configured for that. I'm going to pick up my cell phone here and go to my recent calls and redial. And let's see if we have magic. Hey, come on. Tell me that's not amazing. So every time I say that now, I go back to my I'm just making phones ring. It's cool to make phones ring. So that's where we, again, we now have an FXO port configured for incoming PLAR to where it's now, matching that and receiving it on the incoming. Now we get into the bonus, beyond the home. It's time to reach out to voice over IP dial peers. So I'm going to bring up my console again to the Cisco UC520. And I'm going to create a dial peer voice that is now going to be VoIP. That would be dial peer voice. Let's do 2000, VoIP. And I'm going to do destination pattern. In this case, let's just, I know I only show 2001 down there, but let's say that's a whole office and all the 20 ... extensions exist down at that office. So there's 100-some phones down there that I'm able to call. So we'll make it a little more wildcard-ish. Instead of using the port now, I do session target IPv4 :10.1.1. And this other guy is 10.1.1.2 down here on the other side. I don't think I've set that up yet, but I will. So now I've got the destination endpoint that I'm going to. And that should be it. Now remember, voice over IP does not strip the explicitly defined numbers. That's a POTS dial peer feature, so I don't have to worry about 4 digits. Matter of fact, if I try to do 4 digits, that command doesn't even exist under a voice over IP dial peer. It's only under POTS. So I'm going to exit back out here. And that should be all I have to do from the UC520. I've got that all pre-configured. So now let's head over to the 2600, which has nothing on it. So let's give it hostname 2621XM. And we will go dial peer voice, and let's do 2000 over here as well. But on this side, it's going to be a POTS dial peer. And I'm going to say the destination pattern. Let's make this phone respond to everything starting with 20 ... So our one phone here will represent the entire office, including 2001. And I'll say this is going out port 1/0/0. I think I'm just looking physically at the router. I'm going to do a show voice port summary just to make sure I got that right. Yep, it is 1/0/0 is the port that is going out. And now let's also make the reverse. I'm going to do dial peer voice. Let's do 1100 voice over IP. Destination pattern. See where I'm going with this? 11 ... So this is going to be for the UC520 office. Session target IPv4 :10.1.1.1. Enter. That's where I'm sending it out. So now I should be able to go to either one of these. So I'm gonna call from. Let's go from the UC5. I'm just looking what's plugged in. Let's go from the 2621XM router up. So I'm gonna pick up the phone here and dial. Here, I'll do it. Debug VoIP dial peer. Okay, I'm gonna dial 1102. I love it when my spontaneous recordings just go awry. So, okay, well, it's fun. I mean, because it gives us some troubleshooting capability. Okay, so we've got an outgoing dial peer matched right here, right? right? I'm asking myself. Yes. So we're matching 1100. Oh, wait a sec. Duh. We're not going anywhere. So let's do a IP address 10.1.1.2. Good. Now, okay, now let's do a ping 10.1.1.1. And we've got some basic IP connectivity issues going on here. That's your standard IP connectivity. So let's do a show IP interface brief. This is 10.1.1.2. I'm connected. I'm looking at the cable going to 10.1.1.1. We just hit the up arrow. Make sure it's not just taking some time to come up. No, it's not. So let's jump back over here. See? Phones include IP routing. Show IP interface brief. 10.1.1.1. We're up. Ping 10.1.1.2. Come on, you can't do that. And I'm coming back to the other side. Enter, enter. Right then. We're just taking a little time to come up. So again, just bringing up an interface takes some time. Okay, so now hit the button again. 1102. Ring. Okay, good, good, good. But now instead of just letting it ring, I'm going to pick up and answer that call. So now we actually have an active call in our system. I want to show you a couple key show commands that are handy. First off, the show voice call summary. And right there, I can see that I have voice port, my FXS, that is in a state of connect, and I can see that it is actually using, by default, the G.729 codec. That is the default. So it is assumed compression as the default state. I can also do a show voice call status. And see what DSPs it's using. I can see what dial peers incoming and outgoing it's actually matched. The called number that's going through, and I can even just do show voice call, and I can see all the information. There's not much more to it, but depicting all of those. Now let me do a show call active voice. This is if you really want to get nitty gritty. I want to dig in. I want to see how many bytes have been received. I want to see, the peer ID. I mean, literally everything about the call. How many call legs are actually active? And again, from this router's perspective, this is the 2621XM. I see two active, one incoming POTS, one outgoing voice over IP call legs that are there. I can see how long the send and receive has been happening. How many? I mean, literally everything about this call is being displayed in this output. What port numbers it's actually using for all of its signaling. So again, if you really want to get into the nitty gritty of your phone call, you can do that with the show call active voice. So I'm able to see that. Now let's hang up the call. I gotta hang up my phone. Show call active voice. It's back to 0, so no active calls. I'm going to go into global config mode. Let's do dial peer voice 1100, which is the dial peer from this router that allows it to connect to the main office. And I'm going to type in codec, hit the question mark, and you can see all the different codecs that I can use. I can use codec G711 ULAW, that's the United States, that's my little U. ALAW for another place in the world. I have all these different flavors of codecs, each with different quality, each with different bandwidth requirements. I'm going to convert this system over to G711 ULAW. So hit the enter key and watch what happens. I'm going to dial the number, so let's dial 1102. Phone is ringing. I lift up the handset, and now I'm getting feedback. But now I'm connected to the other side. I hit the go back out here and hit the up arrow. Let me do a show voice call. I can see that we've got show voice call summary. Let's go there. I can see that I now have that connected, and now I'm using the G.711 ULAW, the uncompressed codec, being received over on the other side. So now I have fully uncompressed voice between the two sites. So that gives you an idea of what it looks like when you're assigning voice over IP dial peers. You're setting up voice over IP codecs between the two systems for communication. Awesome. I love it. So what did we see here, and what do I want you to do with this? Oh, how do I even encapsulate that into a statement? We have seen essentially a practical end-to-end scenario setting up most of the concepts that we've seen in this series thus far, and that we're going to build upon, especially as we introduce more and more voice over IP technologies. Now, what do I want to do with it? What do I want to do with it? Everything. I want you, at this point, if you have the ability in your house to do this, to grab just a cheapo router, with some FXS, some FXO ports, and set up a bridge from your home phone into your FXS ports. Now, let me tell you, when I started this, this was I got into voice over IP 2001 time frame. So we're talking close to 11, 12 years ago at this point. I had virtually no experience running cable. So literally, when I said I have FXS ports connected to my HOD, I had duct tape. Now, this was before I was married. I had duct tape going along the hallways holding my analog phone cables because I had to run cable everywhere in my house. I didn't know how to fish it through walls. Now, I've learned since then all of my ninja cabling skills and whatnot, and I got married. And if you're married, the duct tape probably won't fly. But you can set up your entire house with this kind of setup, have dialing between your rooms and all that kind of stuff. But if you can't, let's say you don't have the finances to be able to buy this, head into the office. I mean, a lot of times the office, your boss will be willing to spring for just a cheap lab that you can set up there. And there's all kinds of stuff that you're able to do with this. I mean, take not only what I've done, but take it further. Like maybe start asking yourself questions like, how would I set the caller ID on my FXS port? So when this guy calls this guy, it shows up automatically as the caller ID information, or could change the caller ID to a different number. Maybe how would I have this FXO port wait a couple rings before it answers? Maybe this is a shared line with a couple other devices running off of a splitter, so I want it to wait 3 rings before it answers. I mean, there's all kinds of stuff that you can do once you have a setup like this, and I'd love to use this as a foundation that we can build on as we go through this series. I hope this has been informative for you, and I'd like to thank you for viewing.